Hello viewers, welcome back to my channel. Today I will show you how to perform t-test by using R. First we need to explain what is actually t-test. Actually t-test, or formerly known as student t-test, it actually appropriate if your sample size is smaller, less than 13, sometimes same, and you want to compare with only two groups. Bear in mind, the main difference between ANOVA and t-test is ANOVA, analysis of variance, can work more than two groups. They can work. But t-test only is possible if your sample size is smaller and group is only two. There are two type of t-test. First one is one sample t-test. I will show it here. And another one is two sample t-test, and I will show it again here. First, one sample t-test, that is the compare sample mean with known value. There must be one known value, then we can compare it. I am showing it with a data set. That is, for example, we are talking about plant height. Plant height is plant height. Okay, plant height will be C function, then 45, for example, 50, 55, 60, and little bit lower 48, 52, something like that. These are the plant height. Okay, so now I will check whether the mean plant height is significantly differ from 50 centimeter. Previously I said there must be a known value, so I want to compare that. Plant height significantly differ from 50 centimeter. Which plant height actually significantly differ? Whether this possible or not, we want to check it by using one sample t-test. So our null hypothesis is that this is the mean of plant height is 50, equal 50. That is our plant height mean equal 50 is null hypothesis. So alternative hypothesis will be mu is not equal to 50. It may be differ from significantly differ from the different groups. Let's start. Okay, so t dot test, and then plant height, right, and our mu equal 50. As we told that our null hypothesis is 50, so the mean plant height is 50. Let's see. Okay, this, oh sorry, I forget to run this. Okay, now we can check it. Right, this is the one sample t-test, and our data plant height here, t value is 0.76. What is t value? Actually t value is the difference in sample mean divided by standard error. That is the difference in sample mean and divided by standard error. So here t value is smaller. What it mean? That means the difference between the group mean is lower. So this is high chance that there will be no significance. And then degrees of freedom is 5, as we have totally 6 minus 1, so 5, and p value is 0.4772. What it means? That is, if p value is less than 0.05, then it was significant, but here is greater than 0.05, so this is not significant. Not significant means null hypothesis is not rejected. That means this is not significant. What about our alternative hypothesis? True mean is not equal to 0, right? True mean not equal to 0, as our 95% confidence level interval, the range of the what it called, the range of the mean is between 46 to 57. So this is the confidence interval, and our null hypothesis mean is 50. So 50 is inside 46 to 57, so there is no chance to significant. That's why this is not significant. So the the result is the plant height is not significantly differ from 50. This is the result. Okay, and the sample mean is 51. Okay, so it's done. One sample t-test. Now I will show how to do sample t-test. Two sample t-test. I already wrote a data frame, that is plant height will be 55, 52 and 40, 50. These are the control, and these three will be the water logging. You can also import your data by using here import data set, and then from Excel, and then go there and you can take from there. I'm just showing it here. And then group, that is our treatment group. First three control and second three water logging. So these are my data frame. So data will be data dot frame. We want to organize this pH is dependent plant height, and group, that is our treatment group, will be independent. That's why I arrange in this way. Okay, I'm showing it pH and then group. Okay, you can run it, and then data is data frame dot pH. So right, so we can see the data. Right, these are the data. You can arrange in this way the control and plant height. Here I considered one replication, you can use 3 replication, it will not be a problem. So you can arrange your data in this way in Excel, and then you can insert it, or you can write simply in this way. Okay, so now what is our null hypothesis? Our null hypothesis is mu1 minus mu2 equals 0. What it means actually? Mu1 is the mean of plant height of control, that is a control mean, and mu2 is the mean of water logging, that is the true mean of population, true population mean of group 2, that is the water logging, and true population means of group 1, that is the control. And the difference between the means of control and water logging is 0. That means there is no difference between control plant height and water logging plant height. This is our null hypothesis. So what will be the alternate hypothesis? Alternate hypothesis will be there will be difference between control mean of plant height and plant height mean of water logging. There will be some difference. We will find some difference. Let's see what it actually find in t-test. So we can write t dot test. Sorry. Okay, t dot test. This for t-test, and then our dependent variable is pH, that is the plant height, then tilde. Our independent variable is treatment here consider as group, so group, group, right? Okay, so let's see what this actually all about the t-test. If we do this way, then what happen, right? This show Welch two sample t-test. This is another, this is not the typical student t-test. It goes Welch two sample t-test. Why? First let me explain it. Because when Welch to some t-test came, when the variables are not equal, how you will check? Let's check the variables. For variables, then we can check variables. Okay, right, variables, plant height, then plant height, and we want to check the variable of plant height. So the plant height first three group for control group, first three, so it will be 1 2 3, right? Let's check the variance. Variance is 6.33. That is the variance of control group is 6.33. What about the variance of our data is plant height and then 4 to 6. Okay, let's check the variance of waterlogging group from 44 to 46. Okay, yeah, this one is 4. So variance there is not equal. Variance of control is 6.33 and variance of waterlogging is 4. That's why by default R can analyze it Welch to sample t-test. And here we have seen t value is higher, 4.49 is much higher. That means the difference between the sample mean is higher in larger, so high chance to be significant. And here another thing, degrees of freedom is not in a integer form, it's decimal form. It actually in Welch scatter wide formula, they actually adjust t value more concisely. That's why it come in decimal way, and the p value is 0.0122, which is lower than 0.05. That means significant difference found. That means we can reject null hypothesis. That means there is difference between control group mu1 and mu2. So mu1 minus mu2 will not be equal. That is, there is no difference, is not true. So we can check the alternative hypothesis, the true difference in means between group. That means control and water logging groups, there is means true difference found, and this is not equal to 0. This is not 0, that might be something. And the 95% confidence level, the interval is 3.07 to 13. What it means? Actually the difference between the group is here 52 minus 44, almost 8, which you find here, but the difference is not equal to, is not 0. That means 0 is not included here in the interval. What it means? That means it's significant. In another, it's not equal to 0. The difference is 3 to 13. If the 0 is included here, then it will be non-significant. As this is not included, so this is significant. This is another way to check from the confidence interval. So that's why, that's how we can do t-test in two-way in our Welch formula. Let's talk about the student t-test in this way. Then you just need to do little bit more t-test, and then we can check plant height, sorry, t-test plant height till the group, and the data is data. Then what you need to do, you have to do variance dot equal q u a l. Variance dot equal will be true. Then it will show you the true. So now it will direct to the student t-test, not the Welch t-test, because by default it shows Welch t-test, but now it will direct to you the t-test, right? Student t-test. Now it's two sample t-test. This is not Welch t-test. Previous one it showed Welch two sample t-test, but now this one is normal student t-test, two sample t-test. Here we can check the p-value is higher, almost it was the similar as previous. Higher means significant difference possibility, and degrees of freedom is 4. How they calculate? In student t-test, the degrees of freedom for two sample is n1 plus n2 minus 2. That means n1 was 3 and n2 3, 3 3 6 minus 2, that is 4, and p value is 0.01, which is lower than 0.05, that means there is the significance between the groups. And again, the alternative hypothesis or null hypothesis was that mu1 minus mu2 equals 0. That means there is no difference between these two group means of control and waterlogging. So alternative hypothesis, there must be some difference. So the difference is not equal. This there is not 0. It must be higher, and the uh, confidence interval is 3.18 to 13. It will be between these two. The difference between the plant height means of control and waterlogging. So this is not 0. That's why this is significant in 5% level of confidence. Thank you for watching.